Today's video is going to be on ellipses. This is our next conic section. Yesterday we talked about circles. Ellipses are very similar to circles. When we look at the equation, we've got that x minus h, and we've got the y minus k, which is from the circle equation. The only difference is in a circle, all radii are congruent. So we're moving the same distance right, left, up, down in every direction. With an ellipse, the direction you move in the x, left and right, is going to be different than the direction that you move with the y. So we're going to have an x radius and we're going to have a y radius. And then notice that the ellipse equation is set equal to 1. The center is still going to be the same, so we're still going to have a center at hk. Again, the Rx, which we just talked about, is going to stand for the radius in the x direction. And we know that the x direction is moving left and right. And therefore, our R of y is the radius in the y direction. And we know that the y variable is going to move up and down. Something that's completely new is the major axis and the minor axis. The major axis, if you just think about it, major and minor, major is the axis of the larger radius. So the major axis is whichever radius is larger. And therefore the minor axis is the smaller of the two radii. Alright, so let's go ahead and get into graphing our ellipses. When we look at our equation, we see that it's in standard form. We can't graph it until we get into graphing form. And we change it from standard form into graphing form the same way we do for circles. So what we have to do is complete the square. Almost every single thing that we do in this chapter is going to involve completing the square. So it should be fresh in your memory from last chapter. First thing we do is organize our x's together. So we've got that 9x squared minus 72x. And then we organize our y's. So we've got 25y squared plus 50y. And just like before, we're going to move the number over to the other side. So equals 56. And hopefully you remember, yes, we cannot complete the square unless the a term, the square term, has a positive 1 coefficient. So with the x is the first thing I'm going to do. Then I'm going to pull out that 9, leaving us with x squared, and negative 72 divided by 9 gives us a negative 8x. And then we would complete the square for the x's. For the y's, I've got to pull out that coefficient, which is a 25. And when we pull the 25 out, we've got y squared. 50 divided by 25 would be 2y. And then we've got that set up to complete the square. On the right hand side, we still have that 56. So now we're set up to complete the square. We take half of the middle term, a negative 4, quantity squared. We're adding 16. Half of our middle term, which is a 1, we square that 1. We've got a 1 left. We've completed the square, so now we have to factor and get it set up in graphing form. So we've got 9 on the outside. This factors to be x minus 4 quantity squared plus 25. And when this factors, it's y plus 1 quantity squared. Now on the right hand side, we had 9 16s and we had 25 1s. So remember, anything that you add on the left, you've got to add on the right. So we have that set equal to 225. Now if we go back to the equation up above, we notice that an ellipse equation is set equal to 1, right now we have it set equal to 225. So to get that set equal to 1, we divide it by 225. If I divide that, I'm going to divide each of my pieces by 225. So in your calculator, I want to make sure that you are able to do this. You divide 9 divided by 225. You're going to get a decimal. You're not going to use decimals. Do your math frac, and 9 divided by 225, when you turn it into a fraction, is going to be 1 over 25. So what we do is we've got x minus 4 on top, that quantity being squared. The 1, we don't have to write the 1, so we've got a 25 on the bottom. 25 divided by 225, again, you're going to get a decimal, hit your math frac, and you find that that's 1/9. So it's plus, we've got y plus 1 quantity squared on top. The 9 goes in the bottom, equals 1. Now again, it looks very similar to what we have set up here, but we have the whole thing in parentheses in our general form of our equation, so we've got to put the whole thing in parentheses here. Now if I'm going to put this into parentheses, right now these parentheses are being squared. This is a 25 on the outside, so if I'm going to put that on the inside, it would be what number that would be squared. So 5 squared gives me 25. Again, I think to myself, what number squared would give me 9? That's a 3. Because when I distribute that, that would be x minus 4 quantity squared. 5 squared. 5 squared is 25 on the outside. Y plus 1 quantity squared on top. 3 squared would give us 9 on the bottom. So now we have our equation in graphing form. Our center is at 4, -1. Again, opposite of what you see. So we see a -4, it's a +4. We see a +1, it's a -1. The r sub x, that is your r radius, or sorry, your x radius. And we look here, the x's are together, the y's are together. Therefore, 5 is your radius in the x direction. Here's your y's. 3 is your radius in the y direction. All right, we've got lots of information to fill out for ellipses. Your major axis, you'll remember, is going to be the larger. So in this case, the larger number is the x-axis, and that has a radius of 5. The minor axis is the smaller one, which is this case your y, and that has a radius of 3. Now we have some other information we have to figure out. We've got an A, B, and C value. It's not what you typically would think as your A, B, and C. A is the major axis radius. B is the minor axis radius. And to find C, C is representing the distance from the center, and this is going to be for your foci, and we'll talk about the foci in a second. So to find your distance to your foci, you're going to use c squared is equal to a squared minus b squared. So we don't know c, that's what we're trying to find. We know the major axis radius, we know the minor axis radius. So we have 5 squared minus 3 squared. If you forget, just remember that you're subtracting and it's going to be positive, so you take the bigger number minus the smaller number. 25 minus 9 gives us 16. Well, that 16 is for c squared, so your c is 4. So your distance away from the center to your foci is 4. Now your foci are always on the major axis. So they're always on the larger of the two axes. We'll get to our foci coordinates in just a second. Let's start graphing some of this. We know our center is at 4, negative 1. We have that our r of x, our radius in the x direction, is 5. That means we're going to go 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left. Our r of y, our radius in the y direction, is 3. So we're going to go up 1, 2, 3, and we're going to go down 1, 2, 3. That's going to give us our ellipse shape. And you can see that it's kind of in the shape of a football. So the only difference between an ellipse and a circle is the same radius in all directions. An ellipse has different radius. You're going to move a different distance left and right than you do up and down. Now we're going to get to these foci points. The foci are always on the major axis, the larger of the two. So in this case, they're going to be on the x-axis. And we found C as the distance from the center to the foci, and C was 4. The major axis is the x, so we're going to go right 1, 2, 3, 4, and left 1, 2, 3, 4. Those are your foci points. And yes, you have to include this in all of your diagrams. You have to give us, not diagrams, in your graphs. So we have to give those foci coordinates. We can see right here that this one is at 8, negative 1, and that's at 0, negative 1. Alright, turn over to the back page. I know that took a long time to go through. Good thing we only have one more left. What I want you to start with is pausing your video, and I want you to complete the square on your own and see if you can come up with the correct graphing form of your ellipse. Alright, so go ahead and press pause. Okay, see how you did. First, check to see if you got the correct graphing form. If not, you're probably going to have to press pause again and go through my work so you can see exactly where you made your mistake. You should also probably press pause and make sure that you showed the correct amount of work. There's a lot of work to be shown and you don't want to skip steps. The more work, the more points you get. So if you go from step 1 all the way to the answer, you're going to lose a lot of points. Now that we have our equation, let's go ahead and fill in all of our important information that we need to graph. First, the center. The opposite of what we see with the x, which is a negative 3. The opposite there, which is a negative 2. The r of x and the r of y. Just remember the x's are together and the y's are together. So our radius in the x direction is 7. The radius in our y direction is 5. Now, the major one is going to be the larger one, which is the x, and the minor one is the smaller of the two. So our major axis is the x-axis, the minor axis is the y-axis. To find c, we subtract the squares. So we've got 7 squared minus 5 squared. That gives us 49 minus 25, which is 24. Now remember, that is representing the c squared. So we know c squared is 24. If we want to find c, we take the square root. The square root of 24 is about 4.9. We don't want to worry about exact answers here because if we're graphing, square root of 24 is really not going to tell us a whole lot. I'd rather have the decimal to look at so I can count that over. So let's go ahead and start graphing this. Our center at negative 3, negative 2. And our r of x, our radius in the x direction is 7. So we go right 7, we end up at 4. Left 7, and we're at a negative 10. Our r sub y, our radius in the y direction is 5. So we go up 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. Now if we look at our equation, or in this case our inequality, we have a less than sign. That means we're going to have a dashed line connecting our points on the outside. Now we've got our football shaped graph. We still need our foci. And remember, the foci are going to go on the major axis. In this case, that major axis is the R of x. And we're going to go 4.9. So I'm going to go over 1, 2, 3, 4.9. We're going to go left. 1, 2, 3, 4.9. And again, those are the foci of our graph. The coordinates, since they were on the major axis, we went from a -3 that is at 1.9. Our y value there did not change, so it's 1.9, -2. And we go the other direction, that's a -7.9, -2. You can also find this just by taking your center, -3, -2. We have that -3, we're going to add 4.9. We get that 1.9, which shows up there. Take that -3, subtract 4.9. You get the -7.9 seen there. Since this time it was on the major axis, we subtract from the x because that's the major. If y was the major, we would subtract from the y coordinate. In this case, it was the x. Now we still have to shade. So we pick a test point. Again, I like 0, 0. When I plug that in, I find we've got 3/7, so you square that. Take 2/5, square that. Add those two numbers together. Those two numbers are going to be less than 1 when you add them together. So you're going to shade inside of your ellipse. Okay, I know this video went a little bit longer than normal, but we are now done. Just make sure that you've checked all of your work and make sure that you've checked your graph accurately.